Tropical Storm Bertha formed Wednesday morning just off the coast of Charleston, South Carolina, and is forecast to drench parts of the Carolinas and contribute to heavy rains in Virginia during the coming days.
The storm made landfall east of Charleston at about 9:30 a.m. Eastern Time, with maximum sustained winds of 50 miles per hour. The storm was downgraded to a tropical depression as it lumbered inland, about 50 miles north-northwest of Charleston as of 2 p.m. Eastern.
Neither the winds nor storm surge flooding caused much damage, but heavy rains poses the greatest threat from this storm. A widespread 2 to 4 inches of rain is likely, with up to half a foot possible in some areas.
The broader circulation associated with Bertha has a history of producing heavy rainfall. When it moved along the coast of Florida on Sunday and Monday, more than 7 inches of rain fell in Miami, sparking dangerous and widespread flash flooding across the city.
And just when it looked like the deluges were winding down, disaster struck again Tuesday night, when another 7 inches came down in only 4 hours.
Weather forecast for historic SpaceX launch of NASA astronauts worsens some.
Tropical Storm Bertha is bringing a plume of record-high atmospheric moisture, known as precipitable water, surging north, with onshore flow triggering the incessant downpours. During the next few days, the system, which by then will no longer be a tropical storm, will bring scattered downpours all the way into the northeast.
Wednesday morning's weather balloon launch from Charleston measured a whopping 2.31 inches of atmospheric moisture content in its profile of the atmosphere. That surpasses the previous May record of 2.22 inches. That fire hose of tropical moisture sets the stage for copious rainfall in the Carolinas, likely to drastically exceed the output of many weather models.
Miami serves as an example of the storm's rainfall potential. Things ramped up very quickly on Memorial Day in South Florida, when roughly 3 inches of rain came down in just 6 hours. The city's average rainfall for May is just 5.14 inches.
The rain slackened Monday afternoon, with intermittent downpours continuing through the night. An additional 3.44 inches was measured at Miami International Airport on Tuesday, for a total of 7.27 inches in 2 days. This spurred widespread flash flooding in southeastern Florida.
Roadways became rivers as pumps and drainage systems were overwhelmed, the freshwater flooding coupling with ocean splashover to yield inundations rivaling those caused by Hurricane Irma. In fact, Monday and Tuesday's 2-day rain total beat out that which fell during Irma in 2017, and the 48-hour total was the city's heaviest since 2012.
Particularly hard hit was the Brickell neighborhood, where scenes of a seemingly sinking city played out across social media.
Then, it got even worse.
On Tuesday, the National Weather Service in Miami maintained a flash flood watch for the greater Miami and Fort Lauderdale areas, just in case any isolated slow-moving thunderstorms were to develop. Even though the bulk of the rain had shifted well off to the north, aiming toward the Carolinas, meteorologists were suspicious that a spot downpour could crop up in the exceptionally moist air lingering behind. And sure enough, one did.
Between 4 and 8 p.m., an astonishing 7 inches fell, bringing the 3-day rain total to more than 14 inches, the wettest 72 hours in Miami since 2000. Tuesday was also Miami's wettest day since May 22, 2012, when 9.70 inches of rain came down.
While the rainfall is welcome in Florida, coming amid a prolonged drought that featured the state's driest March on record, the abundance of rain in such a short period has caused nothing but problems. Miami is increasingly prone to flood events because of sea level rise from human-caused climate change, which makes pumping water out of the city challenging due to the lack of a downhill gradient between city streets and the sea. In Miami, sea levels have swelled by nearly half a foot since 1996.
Charleston is another location where flash flooding and coastal flooding from high tides and storms are worsening due to climate change. Fortunately, T.S. Bertha's track kept the strongest onshore winds confined to areas north and east of Charleston.
A corridor of flash flood watches stretches from Charleston up through central North Carolina and into southwest Virginia, where a narrow corridor of tropical rains is likely to deposit a widespread 1 to 3 inches of water, with more in South Carolina.
And given recent heavy rains and saturated soils, it won't take much rain to fall in a short period of time to result in flash flooding.
The core of the downpours will ride north and cross the Appalachians, soaking West Virginia and eastern Ohio between Wednesday night and Thursday morning. Farther east, a few widely scattered heavy downpours are probable along the Interstate 81 corridor between Virginia and southern Pennsylvania, with more isolated activity farther east.
There is also the risk of an isolated brief tornado north of Charleston on the system's right-hand side as the storm moves ashore on Wednesday. Landfalling tropical systems often bring about environments of high wind shear, or a change of wind speed and/or direction with height. Wind shear can cause downpours within a tropical storm's rain bands to rotate, bringing the risk of a few waterspouts and tornadoes. The National Weather Service Storm Prediction Center has outlined a marginal risk of severe weather in that area to accommodate such a hazard.
While it's a weak and brief tropical storm, this is the second named preseason storm of 2020. According to meteorologist Philip Klotzbach, this hurricane season is the fifth on record since 1851 with two named Atlantic storms prior to May 27.
Forecasters are calling for a busy Atlantic hurricane season, with a 70% likelihood of 13 to 19 named storms, 6 to 10 of which will become hurricanes. 3 to 6 of those could become major hurricanes of Category 3 intensity or higher.
An average season produces 12 named storms and 6 hurricanes, 3 of which intensify into major hurricanes.